So let's talk about hard surface. What is hard surface? I didn't find a good definition online, but the best I can describe hard surface in the way it is referred to in the gaming industry and in VFX industry, it basically means any prop or object, any model that is man-made. I prefer to say engineered, created by a man. It usually describes vehicles, guns, any type of mechanisms, even architecture, and pretty much most of your, if we're talking about VFX, most of your props. The best definition I found, somebody online said that hard surface is represented in 3D space with non-deforming meshes, which is very accurate because most of the time it will be something that doesn't deform when you're animating it. If you think about a gun or a robot, a mech, you will see how it's moving, the parts are moving, the joints, etc., but the meshes themselves are not designed to be deformed. Of course, the difference is hard surface will be stuff like vehicles and guns, and the opposite of that would be organic, which is various characters and creatures, or stuff like skin and hair, basically something that was not designed. And because hard surface is usually designed, it only makes sense that for that the design stuff has been engineered by a man, right? So in order to get that engineered look, it makes sense to use the engineering tools. In video game industry and in VFX, anything that we're making usually is meant to be representing the real life. It's usually mimicking something that has already been made, or if we're talking about sci-fi, it's something that humanity would be creating sometime in the future. So naturally, if you think about it, in order to be able to manufacture that, we would have to be using CAD. Of course, we're only talking about mimicking the designs. We're not talking about actual manufacturing of the parts or anything like that, unless there's very specific direction that this particular prop needs to be 3D printed, or it needs to exist in real life. We're just talking about this from the point of view of a concept artist and what is easier to do. So in case of creating 3D models that represent hard surface, you really only have a couple of options. You can either do that in CAD, which we're going to be talking about, or you can be doing that using polygonal modeling. Let's quickly define what is CAD and what is polygonal modeling so we have a better understanding of what we're talking about. What it really comes down to is it's just two different ways to describe objects in 3D space. So CAD stands for computer-aided design, and it means basically that computer helps us create, analyze, modify our models. A lot of it is basically calculated for us, and 100% of the time the output will be a file that you will be able to manufacture, 3D print, CNC, just basically turn that into a real life object. And when I say CAD, I mean I'm talking about NURBS and body representation, which is just usually referred to as solid body modeling. These models define the volume of the object, meaning that compared to polygonal modeling, they represent the full volume of the body. In polygonal modeling, we're only describing things with faces. Basically, your models are hollow inside. As you can see in the model on the slide, the body and the topology of the body is completely different. It is described by curves and surfaces, while if we take a look at the sub-D poly modeling, the topology is quite different. You can see that it's all quads. It's represented by polygons, and it has basically a limited resolution, so to speak. I think the best example I can give you is comparison between a JPEG and a vector image, and the polygons are comparable to rasterized images, to JPEGs, and CAD models are comparable to vector. The key difference is that the amount of polygons is limited in sub-D modeling per model, based on the fact that they just need to be rendered quickly in real time. And CAD models are basically solving completely different set of problems. So our task as a concept artist is to know the difference and be able to know when is a good time to use CAD modeling to present our design and when it is better to use sub-D modeling. So if I had to highlight some good and some bad about each method, I would say that CAD modeling is great for achieving incredible complexity in almost no time compared to polygon modeling. It's perfect for operations like subtraction and adding to the shape, so Boolean operations. Those are done effortlessly in CAD, as just like in any solid body modeling. But the negative side here is that it cannot be directly used in production. So, and plus it's not as easily modifiable, but you will be able to understand that once you start working with these files. You will see that some things can be easily changed, but certain things are much easier done in poly modeling. Of course, the benefit of poly modeling is all about real time and how easy it is to adjust the shape on the go, and also the fact that all of the production pipelines are currently built for poly modeling, either low poly or built for sub-D. So you just need to realize that not everything can be solved in poly, and then not everything can be entirely solved in CAD. There must be some sort of a gap, some sort of that can be bridged. Basically, you can start in sub-D and then convert it to CAD and continue working there, which is usually not the case. Usually it's the other way around. You will create your high poly mesh, your almost finished concept in CAD, because it was easier for a certain type of an object, like for a gun, for some sort of hard surface prop. You will take that CAD model, and there's no good direct way to convert it to sub-D, so you will have to retopologize it in Maya or Max or any other software, and in that way you will be able to use that in the production pipeline. I'd say that if you're coming from a 2D background, you just need to try and keep it an open mind towards this method of modeling in 3D space. And if you're coming from poly modeling, try to not to apply your regular logic, the polygonal modeling logic, to CAD for now, because the actual understanding of limitations will come with you using the software more and more. And specifically for that reason, In chapter 4, I'm gonna go ahead and do a breakdown of CAD logic for you and my CAD thinking process. So in a way, you also need to keep an open mind if you've never tried CAD before. But again, if you have already opened the software and played around with it, and you're getting frustrated with the way things are moving, and the way that you cannot move vertices or edges or faces the way that you're used to in poly modeling, I promise that you just need to give the software some time, and the understanding will come to you, just like back in the day when you didn't know the topology and you didn't understand how topology is built. Once you understood the concept, it became natural. So once you spend some time with CAD logic, it will become your second nature, and I will do my best to teach you how to see that in whatever you're designing.